All right, this is another problem where we're going to calculate the empirical formula, but in addition to asking for the empirical formula, this problem is asking for the molecular formula. So it wants you to calculate a molecular formula for NutraSweet. In order to do that, what it does is it gives you a hint. It gives you some information that you're going to use in order to do that. With these types of problems, you have to have some additional piece of information to get the molecular formula, and it's typically the molar mass of the compound. Now, in this case, we are given mass percent compositions and not individual masses. And so what I'm going to do with these mass percent compositions is assume 100 grams. And in that assumption, it makes determining masses very straightforward. So for copper, I would have 57.14 grams. For hydrogen, I would have 6.16 grams. For nitrogen, I would have 9.52 grams. And for oxygen, I have 27.18 grams. And now I have to do a molar mass calculation that allows me to take those masses and convert them into moles. So I'm going to start off with the 57.14 grams of carbon divided by its molar mass of 12.011 grams. And so what do I get from this? 4.757 mole of carbon. Doing the same thing for the 6.16 grams of hydrogen divided by its molar mass of 1.008 grams per mole, I get 6.11 mole of hydrogen. Now, again, let's continue on. 9.52 grams of nitrogen divided by its molar mass, and its molar mass is 14.007 grams. And so I get 0.680 mole of nitrogen. And finally, 27.18 grams of oxygen divided by its molar mass. 1 mole of oxygen is 15.999 grams of oxygen. I get 1.699 mole of oxygen. So what I want to do is I want to transfer these values to my chart so that I can kind of keep track of things. Again, you don't have to do this if you don't want to. It just helps me keep track of the different values that I've calculated. And so I've got 0.680 moles of nitrogen, and finally 1.699 moles of oxygen. Now I need to sort out the molar ratio. And in order to get the molar ratio, I'm going to choose the smallest value and divide all of the other values by that one. So 0.680 is the smallest. So 0.680 divided by 0.680 is 1. 6.11 divided by 0.680 is 9. And 4.757 divided by 0.680 is 7. Now for 1.699 divided by 0.680, I get 2.498. And so it's important to realize that this is 2.5. And 2.5 has a common fraction. And remember, we have to get the lowest whole number ratio of atoms. And all of the first three, 7, 9, and 1, they're whole numbers, but 2.5 isn't. So what I need to do is realize that 2.5 is a fraction of 1/2, And if I multiply any fraction of 1/2 by 2, I get a whole number. So 1/2 divided by 2 is 1. 2/2 divided by 2 is 2. 3/2 divided by, excuse me, let's say that again. 1/2 times 2 is 1. 2/2 times 2 is 2. 3/2 times 2 is 3. 4/2 times 2 is 4, etc. So this will allow me to get 2.5 and convert it into a whole number. So 2.5 times 2 is 5. 1 times 2 is 2. 9 times 2 is 18. And 7 times 2 is 14. So at the end of the day, I get the empirical formula of NutraSweet to be C14 H18 into O5. And so what we've done here is we've calculated the empirical formula of NutraSweet. So we have done one part of the question, but the other part of the question asks us to get the molecular formula of NutraSweet. So in order to calculate the molecular formula of NutraSweet, I calculate the value of the molar mass of the empirical formula, and I compare that to the molar mass of the molecule given in the problem. So let's calculate the molar mass of C14H18 into O5. If I add up 14 times carbon, 18 times hydrogen, 2 times nitrogen, and 5 times oxygen, what I get is 294.30 grams per mole. And so what does that compare to the molar mass of the compound? Well, it's the same. It's the same value. And so what it looks like is that the molar mass of the compound is indicating to me that the molecular formula is the same as the empirical formula. If that's true, then the molecular formula could not be divided by any whole numbers to get a smaller empirical formula. And it turns out that that's the case. C14H18 into O5 is not divisible by any other whole numbers to get a whole number back. And so what do we have here? We also have our molecular formula. Okay.